The traditional multi-layer campus is often called classic three-tier or three-tier design. Now, if we look at this first slide, you'll notice that on the left-hand side, we have something called a core/distribution layer that's there, and then we have the access layer down below that where all of our clients are connected. Now, that's called a collapsed core, and basically the functionality of both the core and distribution have been combined. Now, typically you'll see this if you have a fairly simple infrastructure, or for smaller businesses, they may have a collapsed core and distribution and then access down below that. On the right-hand side of the screen, you see more of the classic designs. We have our core switches up top. We have our distribution switches in between, and then we have our client access or endpoints that attach down toward the bottom. Now, you notice there are little rings around each of the lines that are there, and what they're trying to indicate is that those have been port channeled. So we've actually combined those lines to provide some redundancy and high availability into a port channel. And so we'll talk a little bit more about port channeling as we go along, but just know that the reason we do a design like this is to make it scalable, and they've indicated scalability, also to make it easier to troubleshoot that's out there. And so as you grow, you can scale, and if anything happens to creep in, then it makes it easier to troubleshoot because you have a design that you've built the architecture to, and you can go in and pinpoint more quickly exactly what's going on. It also makes it easier to add functionality to this, because basically we have divided this up physically and logically and functionally in order to have a good base design to start with and build that out on the campus. Let's go ahead and jump into each of these distinct areas and talk a little bit more about those. The access layer is typically all layer 2 or switching layer. And this is where all of your endpoints connect. So on this slide, we show an end user that has a hardwired PC. We have a telepresence unit that's there. We have a handheld unit of some kind. It could be a smartphone. It could be an iPad, that sort of thing, but that's connected wirelessly. And then basically all of those endpoint devices are connected to an access level switch at layer 2. The first thing I'll draw your attention to is you can see we have a single switch at this layer. So typically you will not see redundant switches implemented here, and each device will be homed back or connected to a single individual switch. Now, that doesn't mean we can't build some resiliency in at this level, because we do, and we do it with functionality. Examples of this, we could provide priority for certain devices that are attempting to connect. We can also do things like ensure we minimize the wireless interference that might be going on inside that room, and that the access point would provide a good clear channel and report any other rogue APs from a security standpoint. And even at this level, devices have the ability to provide visibility into what's flowing in the pipe and take action or report that to devices and technologies that can take action based on what they're seeing. And what I'm talking about is something called NBAR, Network-Based Application Recognition. And basically with NBAR, it takes a look at layers 4 through 7 to identify applications that are running, both internal applications as well as commercial applications. It could be FTP, it could be Telnet, it could also be some commercial database application that's running, or it could be something like Slack, which is a public video conference solution that's running, that sort of thing. But it would identify that, and then based on that identity, we could take some actions to either minimize the impact of that particular flow on the network at this level, or perhaps take actions to defend if it looked like it was a hostile type of flow that had suddenly appeared in the network. So even at this level, we have the ability to do that. On this next slide, we depict the distribution layer, and the distribution layer is classically where you will find your services. It also serves as an aggregation point for all of the access nodes going northbound, and you'll notice that some of the access nodes that are there, the access level switches, are actually dual home. They're connected on one switch on one side and one switch on the other side. So there's some redundancy for connectivity coming down from the distribution layer into the access layer as well, to make that access level, a little bit more resilient and more redundant that's there. The other thing I want to point out is that it does provide redundant connections, not just north and south, but also east and west. And so you'll notice those distribution switches are actually sharing a link. It has a circle around it, and that indicates a port channel has been formed on that, been configured for that. So if something were to happen to the upstream switch in that distribution layer, then there would be another switch that could take over to ensure that that traffic is able to go further north and get into the core, and then again out from the campus network. So this is also classically the layer 2, layer 3 boundaries. So you have both switching and routing going on at the distribution layer, so we can route from VLAN to VLAN. So this is where your inter-VLAN routing is going to be going on. But we still have our layer 2 connectivity down into the access layer. When I say we typically find our services here, what I mean by that, it could be IP telephony services, it could be load balancing services, it could be QoS services that are being applied, it could be security services. So any type of thing you could label as a service, classically you'll find it in the distribution layer. In this next slide, we depict the core layer, and the core layer is intended to be lean and mean. Its major job in life is to provide connectivity for all of the switches and hosts and services and things that are down below it, and provide a way to get up and out of the campus network and out to the rest of the world. So it's a high-speed backbone network. It is an aggregation point for the entire enterprise. Now, you build redundancy, much like the distribution layer. Sometimes you'll see the distribution switches will have dual power supplies. They'll have dual supervisors that are there and dual route processors and things like that. So it just depends on how bulletproof you want to make the distribution and the core layers, but you'll also find the same thing at the core layer. And these tend to be some pretty good size switches in a classic enterprise-wide environment. So there's reliability, there's redundancy, there's very fast convergence, and last but certainly not least, typically the core layer is layer 3. You might be telling yourself now, well, hang on a second. We were talking about core, and you told me it's layer 3, so my layer 3 switch is routing? And the answer is yes, it is. So at the core level, what we do is we'll run a routing protocol, and that will attach to the outside network via an additional router, and then there'll be a firewall and some maybe it could be load balancing and any other services you're going to have inside the DMZ that's there, and then it goes outbound to the external network. But yes, layer 3 is typically what you find at the core layer. Now, you might be asking yourself, it's like, well, gee, the networks I deal with aren't all that large, so can I get away with not having a core layer, and maybe I use my distribution switches? And the short answer is yes, you can. But what's going to happen is that those distribution switches, when you're trying to ensure you've got connectivity through all the buildings that might be in the enterprise campus and all of the other access layer switches, you're going to end up with a full mesh. And that's what they're showing you here. So all distribution switches need to be able to get from themselves to all other distribution switches that are in the network. And trying to add additional nodes to this gets to be an unwieldy model at best. So a core is needed. So you can see in this next slide, we've added core switches to that diagram, and it's cleaned it up significantly. Also, we have a demarcation point in between core and distribution. And remember, the distribution layer is where you're going to find your services. And so distribution layer was intended to be both layer 2 and layer 3 because we have layer 2 connectivity to the access switches down below. And we also enter VLAN routing that's going to be occurring. So we're able to segment that traffic and keep that down below in the distribution layer by having a core layer. And this, plus it's more modular. It makes it easier to troubleshoot. It makes for a great demarcation point coming up out of the campus layer, going out to a service provider, and so on and so on. There are many, many, many good reasons as to why you would want a core layer. A couple of parting thoughts based on years of experience working with Cisco Technologies. Do you have to have a core layer? Do I have to have a distribution layer? Can I get away with a collapsed core? The bottom line is there are no hard and fast rules for building out a network. I just know that this modular design seems to work best that's out there, and there's no hard and fast rule for exactly how many switches you have to have and exactly how much redundancy you have to have. So this is a logical construct that you can use to the best of your ability. But just know that one size does not fit all, right? But there's enough wiggle room inside the design that you can do what you need to do and still gain all of the advantages to using a multi-layer modular design like what we've talked about. In this next slide, we show a traditional distribution layer design. And you'll notice we have a layer 3 link, so we're able to route up top. So we have a layer 3 link in between those two, and we have two access switches down below. And you'll notice that we have very cleanly put VLAN 30 on the left switch and VLAN 40 on the right switch. And if we needed to route in between those two VLANs, then the routing process up above that, in order to have a loop-free design, would actually help us do the inter-VLAN routing. Now, the real world reality is that I wish it was that clean, right? Most of the time, you're going to have access layer switches that have multiple VLANs on them because there are multiple people sitting on the floors of those buildings that are in different work groups. And so each of those work groups would belong to its own VLAN and have its own subnet. So in reality, those VLANs are going to span multiple switches, and that's typically what you find in any small, medium, large environment. Classically, that's what you're going to find. So if that happens, what we want to do basically, so we have a traditional loop design with VLANs spanning these access switches, we're going to have to block some interfaces, is what we're going to have to do to prevent that loop from occurring. And so down at layer 2, you can run, of course, spanning tree, and it's going to block all the redundant paths to ensure we've got one way in and out on a per VLAN basis. And so that's what they're trying to show you here. In this next slide, we show a simplified distribution layer design. And so what they've done is they've basically collapsed the distribution functionality back, and there's some redundancy there. They indicate that with the dual switches. But we have a VLAN on one side, a VLAN on the other, and you'll notice that we have dual connectivity that's there. And so with that dual connectivity, again, we can port channel that and create a logical bundle of connections going from the access level to the distribution level. Again, what's being indicated is that we have VLANs on each of the individual switches. Those will be different VLANs. And in order to get traffic from one VLAN to the other, we would need to route in between that. And the term they use is inter-VLAN routing, because each of those VLANs would have its own subnet. And so to route in between those subnets, we need a route process as close to that as possible. And they've actually included that in the distribution switch that's up above. So again, this falls back to the comment I made earlier. It's like distribution classically is looked at as both layer 2 and layer 3. With layer 2, if we have VLANs are going to span those access switches, then what we can do is use trunking in order to ensure that the clients can access both sides of that and they're all in the same VLAN from a layer 2 perspective.